What's up guys, welcome back to the channel. In this video we're going to be doing a practical introduction to data science using the Spaceship Titanic Dataset from Kaggle. So let's get started. So to get started, what we're going to do first, I'm going to come over to VS Code. So first things first, I'm going to create a Jupyter notebook. We're going to save it as Data Science Intro Space Titanic Kaggle, because why not use a gigantic name? And all right, so this practical introduction to data science using this data set is going to be composed of a few basic things. And the idea here is to keep it kind of simple as far as data science goes, because we want to make it a practical introduction to data science, right? And the way I like to think about it to get started with data science, if you already know a little bit about coding and Python, etc., is to think about a loop that you're going to repeat over and over again. And that loop is composed of the following steps. And that loop is composed of the following steps. In a simplified form, data cleaning. So we have data cleaning, we have analysis, we have modeling, and then let's call it repeat. And then let's call it, so we have modeling and then we have review. Now, there are many ways to extend the cycle. Some people go through like data cleaning, pre-processing, feature engineering, and then analysis and data exploration, and then modeling, experimentation, evaluation, hyperparameter tuning, reporting, etc. There are many ways to build a cycle. The reason why I like this version is that it's super simple and allows you to understand the core of doing data science, so handling data and producing, working on a model, etc. And I think that this data set is a great example of, this data set is a great way to get started. This data set is a great way to get started. This is an overview of what we're going to be doing today. So first we're going to download the data from Kaggle. Then what we're going to do is we're going to clean the data, right? We're going to do a little bit of data cleaning. Okay, so now let's see how that looks in practice. So I'm going to head over to Kaggle. I already have the website open up here. And what I'm going to do is very simple. I'm going to download the data. If I go down here, I have this command that I can copy. And if I put an exclamation sign on the left, I can call this command as if I was in the terminal and download the data. So let's do that. Perfect. And now, if I just do a ls here, we can see that the data was downloaded. Now the second thing I'm going to do, so I'm going to unzip that zip file that I just downloaded, which is the Spaceship Titanic file, and save it in my current folder. And now if we do that again, we can see, and if I hit ls directly here on the notebook, we can see that the train.csv file with the training data we're going to be using to do the modeling, the test.csv file where we're going to run the predictions and then submit them to Kaggle. And we have an example of a sample submission, which is going to be useful to know what's the format and structure that we need to submit our submission to Kaggle, right? So that we can go to the leaderboard and whatever. Okay, so let's get started. So how do we get started with, doing some real data science? Well, first things first, we're gonna load our data, right? So usually we do that by using pandas. So I'm gonna just import pandas here, and I'm gonna just separate this stuff. So I have this, I imported the data, and now I'm just gonna read the CSV with the training data, which is right here. But to be smart, I'm gonna set this to be a variable called file path, or whatever I want to call it, because then at the end this is going to be useful because I can do some transformations on this string to do certain things automatically when I go to save the submission and submit. So perfect. So now that I did this, we can call df.head to take a look at our data. Perfect, I don't know. Let's just put it a little bit smaller so that you guys can see. So as we can see, we have this data, and basically we have a passenger ID, home planet, cryo sleep, a cryo sleep column, cabin column, destination column, age column, VIP column, room service, food court, shopping mall, spa, VR deck, name, whatever name that is, and whether or not it was transported. So obviously we don't know what any of that means. So the first step in doing data science and data cleaning, is going to be to understand what data we have. So how do we do that? Well, let's head over to Kaggle and take a look at an explanation of each of the data field descriptions. We're going to take a look at an explanation of each of the features that we have in our data set. Since we have this, since we have it here, what I'm going to do is I'm going to copy this description, okay, and I'm going to save it right here as data description, just so that I can, access it and take a look at any time I want. But when I do that, it doesn't look so good formatted. So what I'm going to do is I'm going to do a print screen of this so I can have it in my Jupyter notebook. So that's what I'm going to be doing here. And there you go. And now I can paste it directly on my Jupyter notebook. I can do that because I'm using a very cool extension that I can show you guys right here, which is copy paste image, something like that. Paste image, yeah. This is the extension that I'm using to be able to do this kind of stuff on Jupyter Notebook. If you guys want to check that out, this extension is freaking awesome. Okay, so now we have an explanation of each of these features. Let's take a look at them. I'm gonna get rid of this, Let's, I don't want to have the terminal here. Perfect. So passenger ID, as we, obviously we could assume is the unique ID for each passenger. So each ID takes the form GGG_PP, where GGGG indicates a group the passenger is traveling with, and PP is their number within the group. Perfect. Okay, so we have a group and the passenger. We have a group, and then we have the passenger number. The home planet column is the planet the passenger departed from, typically the planet of permanent residence. Let's do that again. So home planet is the planet that the passenger departed from. So home planet is a feature that indicates the planet the passenger departed from. So where the passenger came from. Cryo sleep is a feature that indicates whether the passenger elected to be put into suspended animation for the duration of the voyage. Okay, and then passengers that are in this call, and passengers that are in cryo sleep are confined to their cabins. Okay, whatever. So it's some condition where the passenger elected to be put into suspended animation, whatever. Okay, and as we can see from the table, cryo sleep is a Boolean. Home planet is a string, and then cryo sleep is a Boolean column. Perfect. Then after that we have cabin, which is the cabin number where the passenger is staying. Okay, so it takes the form of deck, number, and side, where side can be either P for port or S for starboard. I'm looking at this and I'm already imagining that we're going to be able to do some data processing where we're going to be able to create other features from features like cabin, because it has a lot of information within it. You see deck, number, and side, where side can be port or starboard. So I'm already imagining something like, having a column for deck and having a column for side, but so far we're just taking a look. Then we have destination, and then destination is the planet the passenger will be departing to, so where people are going, obviously. And then age of the passenger, and VIP is a Boolean. Yeah, okay, so VIP is a Boolean that indicates whether or not the passenger paid for a special service. Okay, so probably a feature like that would be a good indicator of the socioeconomic status of the passenger, which I assume based on the Titanic dataset and all the processing and cleaning that you do on that dataset, that the socioeconomic conditions of the people on board were somewhat correlated with their likelihood of survival. So in this case, I assume that there's going to be some relationship between that as well. Finally, we have room service, food court, shopping mall, SPA, spa, and VR deck, which is the amount the passenger has billed at each of the Titanic's many luxury amenities. Okay, so all right, so we have these features: room service, food court, shopping mall, spa, and VR deck, and how much they spent on these amenities that were inside the Spaceship Titanic, whatever that is. Okay, so how much they paid for each of these amenities. And then the first and last names of the passenger. Okay, great. And finally, transported, which is going to be, transport is going to be our target variable, right? We're going to be trying to predict transported. So that's whether the passenger was transported to another dimension. This is the target variable, the column you're trying to predict. Perfect. And as we could have imagined, transport is a Boolean, right? It's true or false, whether or not it was transported to an alternate dimension. Okay, that's perfect. So now what we're gonna do, let me just adjust something here. 1 sec. Okay, look. All right. Cool. Okay, so now that we have an idea of what the data is, we can start doing some data cleaning. Now, before we get into, removing nuns and getting into the entire pipeline, let's just take a look at the data. And the way that we do that is by considering the type of data that we're looking at. We're gonna just print out some information, some basic information about that data, okay? And the way that I want to do that is I want to do that systematically. So to do that systematically, what we're going to do, let's write up here data cleaning and pre-processing. Okay, yeah, let's write up here data cleaning, and we have data cleaning in data cleaning. The first thing we're going to be asking is which features are categorical and which are numerical. Once we know that, the second thing we're going to do is we're going to be looking into the available data types, and then none. And then we're going to be looking at none, blank, or empty values. And for data cleaning, this is going to be our basic, let's say, template for now. Okay, so we're going to take a look at we're going to separate the features into categorical and numerical. We're going to take a look at the available data types, and then we're going to be looking at whether or not we have none, blanks, and empty values. And what we do to these, what we do in each of these situations is going to be something we're going to be talking about as we go. Okay, so let's start with features. So let's write it like this. And which features are categorical and which are numerical. And Now what I can do is I can come here and I can say, okay, perfect. I can to do that in pandas. So to do that in pandas is quite easy. We can just call df.info, and what we get here is information about the types of columns that we have. So we can see that passenger ID is a categorical variable. Here the data typing object only means that we're not gonna go into specifics on data types. Let's just take it home that in this case, data type being object means categorical, and data type being a float or an integer means numerical. And we're not going to look into, ordinal variables versus continuous variables. We're going to try to keep it simple so that we move along faster. Okay, so we can see that we have a bunch of these are categorical variables, and we've got age as a numerical variable. And we got room service, food court, shopping mall, VR deck. Perfect. So to make it, in order to have more control over the information about categorical and numerical variables, we're going to create a simple Python loop where we're going to say, okay, so for columns in df dot get categorical, for calling df.select dtypes, and then we're going to say include equal object like this, right? And then I want to say dot columns so that it returns the columns that are objects, meaning in this case categorical variables, and then I'm going to print it. I'm going to print those columns, and to be more organized, what I want to do is print here categorical variables. So this is the output. So when I run this is what I get. Perfect. So these are the categorical variables that we have: VIP, name, destination, cabin, require sleep, home planet, passenger ID. I feel like nothing was left behind. Perfect. And now for the numerical variables, I'm going to do the same. I'm going to do a very similar approach. So numerical variables, and now for call in df.get numerical data, get numeric data dot columns, which is the pandas method to be able to get to allow us to get the numerical variables, and we're going to print those columns as well. Okay, so then we'll run this. Here we have it. So now we have our numerical variables and we have our categorical variables. Perfect. Okay, now I would say that which features are categorical and numerical, we have that information. The available data types. To get the available data types, what we can do is we could use just df.info, but we can also use df.dtypes, and that would just give us a very nice print of the data types available. And I guess for this part, this is what we're going to do. And now we can move on to something that's more data cleaning like, which is to look at none values, blanks, and empty values. So to do that, we want to, the way that I like to do this is, there's like 1,000 ways. This is the way that I can think of right now. We're going to do a loop in the data frame. So for each column in that data frame, we want to print the name of that column and then the number of nones of that column. So this is what this part here is doing. And when I run this, did a mistake because I didn't say for call in. Perfect. So now, there we go. So now we can see all the columns that have some kind of non-value, or now we can see all the columns that have some kind of non-value. So we have 200 non-values for home planet, cryo sleep 217, etc. So quite a lot of non-values. And let's take a look at the size of our data frame, just to have an idea of what these numbers mean in terms of percentage of just to get an idea of what these numbers mean in terms of percentage of the entire data set. So let's run again the same loop, but this time I want to get this divided by the length of the data frame, and that will give us in percentage what is the ratio of values of that column that are actually non-values. And to make it pretty, what I can do is I can do like this. I can create a variable called percentage no values, and now we can say string this plus a percentage sign, and I think that will look a little bit better. And when I run this, there we go. So as we are looking here, the percentage of non-values is relatively small, I would say, so 0.02, 0.02, so 2% of the data. I mean, that's small or big depending on how much data we have. So let's take a look at how much data we have. The length of the data frame, we don't have a print, we don't need a print here. So out of 8,000, 2% of 8,000, let's see, 0.02 multiplied by 8,693, okay. Yeah, I think that for today, for this time, what we're gonna do is we could, so there are quite a few approaches to handle non-values. We could so approaches to deal with non-values. We could replace non-values with the most common value in the column. In the case of categorical variables, we could do things like remove the rows that have non-values. We could replace the values with the mean for numerical values, and it's important to note that in this case the variable has to be continuous, right? Because if we have some kind of ordinal variable, and ordinal means just a number that represents let's say a grade, for example 1 to 10. If we replaced with the mean, we could be replacing with a value that actually doesn't exist in the data. Say that the grades were only, between 1 to 10, and you give it a 7.5. That doesn't exist in the data, so it doesn't make sense to put it there. But for continuous variables, we could replace the values with the mean. That's totally possible. And there are many other options. I think that for this one, I'm going to look into dropping these values and seeing if that would be too damaging to our data. So what we're gonna do is we're gonna repeat that loop. We're gonna repeat this loop, and we're gonna say for call df.columns, I'm gonna say df.drop none, and the subset is going to be call, and then in place equal true, because that means that it will actually transform the actual data frame, so I don't have to reset it to a variable again. And now when I call df.head, let's see what happened. Okay. Let's see, the length of our data frame after doing that is 6,606. Now that's not very good, because that means we took way too much data from the data frame. So instead of doing that, I'm not a big fan of reducing that much just because it had an unvalue in the row. So instead of doing that, I actually will try a different approach. However, I have to read the data set because I set it directly to, because I applied transformation directly to the data frame, to the df variable, and that's actually not good practice, so don't do that at home. So I'm gonna do all the stuff again. I mean, I don't have to run this again, nor this again, nor this, nor this, and nor this. All right, okay. Okay, so instead of removing, we're gonna be looking into replacing the non-values with the most common value in the column. So we're gonna be looking into replacing, because I think that replacing here, it's probably the best approach. So to do that, I'm gonna do like this. I'm gonna get the categorical variables. So I need this loop. I'm gonna do something a little bit smarter, which is I'm gonna say categorical variables equals to this, so I can access as a list. So now this allows me to access the categorical variables as a list. And now I run this. Now I have them accessible. I'm going to do the same for the numerical variables. So numerical variables is equal to this. And now I'm going to replace it here with that. Remember that I'm doing this on the fly today, so that's why this is going to be a bit more like full of these little interludes of me figuring stuff out on the go. Because I thought it's a closer look into what doing real data science on the fly looks like. Because I could prepare something far ahead, and there's like a place for tutorials like that, but I think this one is interesting because it kind of like shows you the mental frame that you have to be in to be doing data science. What do you have to think, and how do you think, how you make those decisions, etc. But let me know in the comments if you guys like this approach. Okay, so for the categorical variables, I'm gonna say here, categorical column in categorical variables. I'm not gonna print. What I'm gonna do is, let's take a look at the variables again. So we have transit, cabin, destination, age. Okay, so for categorical variables, we're going to be doing this approach of replacing the values with the most common value in the column. And for numerical variables, we're going to replace the values with the mean. Okay? This way we have a standardized approach. There we go. And I don't like it written like this, so let's put it like this. Okay, perfect. So this is going to be our approach. And since I have the categorical variables here, I can say for categorical column in categorical variables, I'm gonna say df.fillNone, df column.fillNone, and then this gives me the most common value. This gives me the most common value from that This gives me the most common value from that data frame. And it replaces it directly. Okay, cool. Perfect, done. Now we can check whether or not this worked by doing for categorical column and categorical variables, print df call dot is null dot sum, and hopefully when we do this print, we're gonna get a bunch of zeros. There you go. Oh, sorry, that was mistaken. Oh, so we didn't. Okay, that's no good. Okay, got it. Yeah, because this in place equal true doesn't work. What works is this. Yeah. And now he's saying no, perhaps you forgot a comma. So no. Oh, we have this thing here that shouldn't have been here. Okay, so now we run this, and now when we run, okay, let's see here. Okay, perfect. Categorical column. That's true. So let's just run that again. So I made a mistake here. Okay, perfect. Now we got it going on. Yeah, that's all good. So I made a mistake there, but now it's all good. Okay, so now we can run this. Perfect. And then we can run this to check whether or not we actually replace the values and there are no more nones. Perfect. We have no more nones. We replace with the most common value for each of the categorical variables. And we're going to do a similar thing for the numerical variables, but instead of replacing with the most common, we're going to replace with the mean. Now we should take a look here just to see if replacing with the mean in any of these examples is going to give us some kind of bias or some kind of mistake. But I'm guessing that doesn't seem that that's going to happen. I mean, we have age, replacing with the mean age, I guess it's fine. Room service, also fine. We replace it with the mean. I mean, yeah, that's true. Replacing with the mean is not necessarily the best approach, because in normal distributions, when we have values that are at the tail of the distribution, tend to skew the mean quite a bit. But we're not going to think about that right now. I'm not going to get super worried about that right now. I'm just going to, for numerical, I'm going to apply the same approach. So for numerical variables, numerical call, same thing, perfect. And now I just do the same thing I just did back then, which is non-call. Okay, great. So no more non-values. And there are many ways to do that. There are better ways, but for this introduction, for this kind of like first look into how to look at these things, this is what we're gonna do. Okay, perfect. Now that we have all of that done, I guess that for this simplified data cleaning step, we're gonna be done. And we can move on. So we can move on to the next step, which is going to be analysis, or data exploration, whatever you want to call it. So analysis, we're going to do a few things. We're going to do a bit of data exploration, which we could have done before data cleaning. Some people do before, some people do after. Once we've look into what transformation we need to do in the data. I wanted to do something a bit quicker for this video, so I'm gonna be looking to some of the characteristics of the data right now. And so we're gonna do data exploration and probably a little bit of feature engineering, and then a little bit of data visualization. Okay, so for the data exploration phase, let's look at things like the statistics of our data set. So we can call df.describe, and now we can say include. Yeah, we want to look into the statistics of all the variables that we have, including the categorical variables. So there's a thing that I can do here. Oh, yeah. There you go. There's a thing I can do here, which is this. And now, there we have it. So I'm gonna do this in two parts. First, I'm gonna call df.describe to get the statistics of all the continuous variables we have, all the numerical data we have. And then I'm gonna do for categorical variables. So here on top, we can look at, the mean age is 28 years old. The standard deviation for age is 14. The minimum wage is 0, which is weird. Maximum age is 79. I mean, I guess minimum wage being 0 means that it was, some baby or child. I guess that minimum wage 0 means that it was a baby that was less than 1 year old. Room service, food court, shopping mall, we can look at mean, standard deviation, and so far so good. And for the categorical variables, we can look at specific information regarding home planet, cabin, destination, and name. So the unique values in passenger ID is the same as the count because it's passenger ID. And then home planet, we have 3 unique home planets. For cabins, we have many types of cabins, which is interesting. But it's probably because, cabin looks like that because, cabin has a bunch of information inside of it that we can actually explore a little bit for feature engineering. Finally, we have 3 types of destination. The most frequent cabins, 207, most frequent destination is 609. The most frequent cabin is this cabin with 207 unique values, with 207 values. And then the most common destination is this Trappist 1E, whatever that is. And finally, the most common name is Aureum Desivering. And it's kind of funny that's actually very interesting. There's one name repeats itself quite a bit. That's funny. Let's take a look at that. Name equals to this thing. So I'm going to copy this. And look at that. We have a lot of names. Aureum Desivering. That's interesting. Okay, so a lot of people with the same name in this ship. Fascinating. Oh no. Ooh, that's no good. That's because that is my mistake. Because I replaced with the most common. Yeah, that's no good. That's no good at all. Okay, so I just identified a mistake that I did. Now, I thought it was weird that you had 202 names that were the same, right? Because names are supposed to be unique. However, there are a bunch of non-values in the name, and I used an approach of replacing the most common value. So what it did was it got the most common value, which probably was like, had 2 repetitions of this name or something. and replaced all the nuns with array and persevering. And now that's a problem, because if we use this feature, if we use the feature name to do any modeling, if one name repeats itself 200 and something times, it could give us some issues. So we're gonna have to look into that. So that was my mistake. Okay, so we're gonna go back to categorical variables. And I'm gonna say this. I'm gonna come here, I'm gonna say if cat call is different than name, we do the thing that we wanted to do. This way, we're gonna avoid that issue that we just had there. And I'm gonna rerun this. Now, this is not the best approach to be rerunning the cells every time you do any kind of mistake and stuff. So we're gonna start doing things a bit smarter. But for now, it's fine. We don't have to, haven't done anything too complex to need, some optimized approach or anything like that. We have all the stuff that we need. Yeah. Okay, so now we can run this and we can do this. And yeah, as we can see, name, it has 200 none values. Just drop that column from our data set. And now we're gonna plot the categorical variables. And as we can see here, we have a bar chart with home planet, destination, cryo sleep, and the VIP variable. I'm plotting now the value counts for the VIP and looking at the unbalanced distribution of this variable. And I'm gonna do something similar for the numerical variables, dropping the transported variable from the training data. And this is what we're seeing here, a distribution of all the continuous variables we have in our data set, spa, age, etc. For the feature engineering, I'm going to be building two features out of the cabin column, one for deck and one for port. And I changed my mind about building this feature called group from the passenger ID column because it wouldn't work. So here, this is what I'm doing. So applying a lambda function to that cabin column that fetches the deck information from the string. For the port column, I'm doing the same thing. And then finally, I'm just mapping them to numerical values and then dropping the cabin column. For the home planet variable, I'm just mapping the feature names to numerical values. And here I'm doing the same thing for the destination column. Now for the training data, I drop the passenger ID column, which we're not going to use for modeling. And then I apply the same transformations to the remaining categorical variables, the VIP and the cryo sleep. I map them to numerical values. I then call final.df.head and save the file as train.clean or test.clean. Now we can get into modeling. For modeling, we're going to be doing first train test split of our training data. We're going to feed a few models, and then we're going to plot the results and pick a winner, and then submit our predictions. Here we are fitting a logistic regression model, a random forest classifier, and a gradient boosting model. And I also quickly want to add a support vector machine approach. Once we have all the scores, we can save them to a data frame and plot them using Panda's built-in plot method as a bar chart so we can evaluate the performances. As we can see, the models perform relatively the same, with the gradient boosting model having a slightly advantage over the other models. And finally, we can now generate the predictions based on the models that we just evaluated and submit them to Kaggle. This is the command that you use to submit your final predictions. We save the predictions to a data frame that has a passenger ID column and the transported columns with the predictions that we just generated. In this case, I'm going to be generating predictions based on the support vector machine model. And if I head over to the Kaggle website and click on submit predictions, I can look at my latest submission. And as we can see, my performance was 78,933, and that's it. If you like the video, don't forget to like and subscribe, and see you next time. Cheers.